Okay, so today we're looking at the integration of the reciprocal function and that results in a logarithm. And from the work that we've done earlier on differentiating logarithms, we know that when we differentiate a logarithm, we end up with the result, the derivative of the function over the function, so f dash x over f of x. So then it makes sense that the integral of f dash x over f of x would give us this result, which is the natural log of our function plus c. And we've explored that earlier in the slide presentation. However, we need to think about why it's the absolute value of this function, and I want you to think about logarithms and what you know about a logarithm, and that is you can only find the log of a positive value for x. So x must be greater than 0. So in other words, if we've got a function here, then the whole function needs to be greater than 0 or positive. So that's why we're taking the absolute value of it. So let's have a look at this question here. Is it in the form of the derivative of the function over the function, or f dash x over f of x? And it is, because if we consider 2x squared plus 1 and we want to differentiate this, we end up with 4x, don't we? So this is in the form that we want it to be in, so therefore our result will simply be the natural log of our function down the bottom, which is 2x squared plus 1 dx. Okay, let's look at our next question here. Is it in the form of the derivative of the function over the function? So our function on the bottom is x squared plus 7. What's the derivative of x squared plus 7? Well, the derivative of this is 2x. So it's not in the form we want it to be in. So what we need to do here is take out a constant multiplier so that when we multiply this in, we end up with our original question. So I need to take out a fraction here such that when I multiply these across, these will cancel. So I'm going to put a 2 out the front here. And when I multiply across our numerators, we want to end up with a 3 on the top. So I'm going to take 3 out here. So I want you to look at that carefully. Why have we taken out 3 over 2? Well, by doing that, these 2's will cancel. I'm left with a 3 on top, which is our original question that was being asked of us. So now we've got 3 over 2 times, and we've got it in this form. So we're going to use the result from the reference sheet, which is the natural log of the function on the bottom, which in this case is x squared plus 7, and we're taking the absolute value of it because this function needs to be greater than 0 to find the log. Okay, let's have a look at this next question here. Again, let's start by thinking 2x cubed minus 7. What's the derivative of that? When we differentiate this, we end up with 6x squared plus 0. Now, is this the same as the question that was being asked? No, so let's think about taking out a common factor such that when we multiply in, we end up with the same as the original question that was being asked of us. So let's put a 6 out here down the bottom so that when we multiply this in, our 6's cancel. And what are we going to take out the front? Well, we won't want this coefficient up here to be 1, so let's take out 1/6. So I've got 1/6 times, now it's in this form, f dash x over f of x, so I can use my result from the reference sheet, which is the natural log of the absolute value of this function that's below, which is 2x cubed minus 7, and then plus my constant c. Okay, this question looks like it's presented slightly differently, but this is just a 1 dx. So this would be the same as rewriting the question as 1 over x plus 3, and we're going to integrate that with respect to x. And this is already in the form of the derivative of this is just 1. It's already in the form we want it to be in. So then our result is going to be the natural log of the absolute value of our function, which in this case is x plus 3, and the absolute value of that plus our constant c. Now, what's the difference with this question? Look at the word here. It's asking us to evaluate. So we want a numerical result for our answer. And the reason we want a numerical result for this question is we've got a definite integral rather than an indefinite integral. So let's rewrite this like we did with the previous question. The integral from 2 to 5 of 1 over x plus 1 dx. Now let's integrate our function here. And it's in the form of the derivative of the function over the function. So again, we use our result from the reference sheet, which is the natural log of x plus 3. And we're going to evaluate that between 2 and 5. Why have I not worried about the absolute value sign here? Well, I'm substituting in positive integers, so my values for x are going to be positive anyway when I substitute it in. Okay, now, first of all, substituting in the natural log of 5 plus 3, and then minus the natural log of 2 plus 3. So we end up with the natural log of 8 minus the natural log of 5. 5 and 3 is 8, 2 and 3 is 5. Now, because we're subtracting, we could apply our log laws here and rewrite this as the natural log of 8 on 5 as our final answer.